To simulate the evolution of a glacier, one needs a mathematician and a glaciologist. The mathematician computes how the glacier moves under its weight. In fact, ice is like a viscous fluid moving very slowly under gravity at a monthly scale. A more well-known viscous fluid is honey. Here you can see how similar they are to each other. The velocities of each ice particle are described by fluid mechanics equations. In practice, these equations are so complex that it is impossible to solve them exactly. Instead, mathematicians have designed algorithms that estimate the velocities along the glacier. Let's look at the result, the velocity field of the Rhone Glacier in 2007. The arrows represent the direction and the distance the ice moves. Here red arrows represent velocities as fast as 100 meters per year. The glaciologist computes the accumulation and the melting of ice due to weather conditions. On the one hand, the melting depends on the air temperature and the exposure to sunlight. On the other hand, the accumulation depends on snow precipitation. Computing the difference between the accumulation and melting over 1 year, we can obtain the mass balance. The mass balance is usually positive at the top of the glacier and negative at the bottom. Let's look at the mass balance of the Rhone Glacier in 2003, well known for the summer heat wave. A lot of mass was lost as seen by the wide negative area. In contrast, there's a small positive area at the top. If we know the shape of a glacier in a certain year, the mathematician computes the displacement of the surface during that year. Then the glaciologist corrects the surface to account for the mass balance of the same year, and so on. Using past temperature and precipitation data, the evolution of the Rhone Glacier can be reconstructed. The results show that the simulation fits the reality well. Of course, no temperature or precipitation data are available for the future. Instead, we can consider different possible climatic scenarios. For example, a realistic increase in temperature would be around 4 degrees by 2100. According to this scenario, the glacier should vanish by the end of the century. But if we reverse the climatic trend by considering a new ice age, a totally different future occurs. Now it's your turn. After this film, you will have the opportunity to choose from different climatic scenarios for the 21st century and see what could happen to the largest glacier in the Alps, the Aletsch Glacier.